here we have a simultaneous equations question combined with some curve sketching, and this is taken from a past paper, C1 January 2007, and this is question 10 on that paper, and it's worth 13 marks there, 6 for curve sketching and 7 for solving simultaneous equations. So it's definitely one that you want to attempt. You don't want to miss out on all of those marks. So part A says, on the same axes, sketch the graphs of the curves with equations y equals x squared multiplied by x minus 2 and y equals x multiplied by 6 minus x, and indicate on your sketches the coordinates of all the points where the curves cross the x-axis. So let's put some axes in. Here's my y-axis and here's my x-axis. And my first curve is a cubic. Okay, because if I multiply that out, I'll get x cubed minus 2x squared. Highest power is 3, it's a cubic, and it's a positive cubic, so it's going to have this shape. Now, I need to know where on the graph that's going to be, and I do that by looking at the roots. This is equal to 0 when x is equal to 0, which is a repeated root, or when x is equal to 2. So let's just put those on the graph. There's 0 and 2. Okay, no, I'm going to need more space on there, so I'm going to move this down a bit. Okay, so the fact that x equals 0 is a repeated root means that the cubic will touch the curve x equals 0 and bounce off, coming away again, turning and then going through x equals 2. So it will look like this. A little like that. I mean, you could probably draw better than this. So that's my cubic. That's my first curve sketched on there. My second curve is a quadratic. If I multiply that out, it's 6x minus x squared. It's a negative quadratic. So it looks like this. So I need to know where it cuts the axis. So where are the roots? When does this equal 0? This equals 0 when x equals 0 and when x equals 6. Nothing special about these roots. They just cut the x-axis at 0 and at 6. So let's put 6 on here. So I need to get my negative quadratic on. So let's do something like this. Okay, so let's emphasize that other intersection there. Okay, so there's my two curves, and that's my 6 marks. I haven't got any other interest in intersections, so no y-axis intersections. They're both at 0. So that's all done. And in part B, I have to use algebra to find the coordinates of the points where the graphs intersect. So we've got, this one is y equals x squared times x minus 2. And this one is y equals x times 6 minus x. And I'm going to highlight the 3 intersection points. Okay, so y equals x squared times x minus 2, y equals x 6 minus x. I'm writing those down again because I'm presenting them now as simultaneous equations. So to solve simultaneous equations, I have the x and the y values being the same simultaneously, so at the same time. So I can substitute my expression for y of one of them into the other, giving me x squared times x minus 2 is equal to x times by 6 minus x. Now I'm going to multiply those out. X cubed minus 2x squared equals 6x minus x squared, and move everything onto one side. So plus x squared on both sides and subtract 6x. And that's equal to 0. I have to solve this cubic, which clearly has a factor of x in common in each term. So I can write this as x multiplied by x squared minus x minus 6. And I can go on to factorise the inside as x minus 3 times x plus 2 being equal to 0. And now I can solve this cubic by identifying the roots. This gives me x equals 0, x equals 3, or x equals minus 2. I've got 3 numbers multiplying together to make 0. Each one of them could be 0, so I get 3 solutions. So the question says use algebra to find the coordinates of the points. So we've got the x values. Now we need the y values, and I'm going to use the quadratic. I'll put my x values in there because it's easier than using the cubic. So y would be equal to 0 times 6 minus 0, which is still 0. 3 times by 6 minus 3, which is 3 times 3. And minus 2 times by 6 minus minus 2, so minus 2 times by 8 is minus 16. So let's just have a look at the curve to see if that looks about right. So there's my 0, 0. That looks right. There's my 3, 9. Here, that looks about right. And that must be minus 2, minus 16. So that all looks good. So just make sure that you write your intersection points down explicitly. 0, 0, 3, 9, and minus 2, minus 16. And that completes the question. So check out studywell.com for more of this.